Assalamu alaikum, dear students of standard 9. How are you? Hope you all are fine. So welcome back to my physics class. Dear students, today I will start a new chapter that is named as Refraction of Light. This is chapter 9 from your physics book. So let's start the class. So at first, I want to make you clear what is refraction of light. When the ray of light travels obliquely from one transparent medium to another, the bending of ray of light at the surface of separation of the two media is called the refraction of light. Look, here, this is incident ray. This ray is incident from the rarer medium, that means lighter medium, to the denser medium. So here, this is incident ray. This perpendicular line is known as normal, and this line is the line of separation separating two medium. Okay, surface of separation. So we can see here the incident ray incident at this point, and the ray should go through along this path like a straight line, but we are seeing the ray of light is bending at the surface of separation separating the two media. So this phenomena of bending of light is known as refraction of light. So look here, the incident ray makes an angle with the normal, which is called angle of incidence, and here the refracted ray makes an angle with the normal, that is known as angle of refraction ray, angle of refraction. Here you are seeing another picture. Look here, light is incident from the denser medium to the rarer medium, and here we are seeing, in the previous case we have seen that incident angle is greater than the refracted angle, but here we are seeing the incident angle is less than the refracted angle. That means in this case the refracted ray moves towards the normal, but here the refracted ray moves away the normal. That means what? When light enters from rarer medium to denser medium, the refracted ray moves towards the normal, but when light enters from denser medium to the rarer medium, then the refracted ray moves away the normal. So now I will explain the laws of refraction. So before that, again I want to summarize what is refraction of light. So when the light ray travels from air to water, the refracted ray bends towards the normal. That means when light enters from rarer medium to denser medium, air is rarer medium, that is lighter medium, and water is denser medium. So look here, I is incident angle, incidence angle or angle of incidence, and R is angle of refraction. Look here, that coming from the air medium following the path AB, light ray incidence at the point B of the separation surface PQ. Separation surface PQ of the two media. If the light ray goes straight, then it should follow BC prime path. But rather we are seeing the light is going along BC. That means light is bending at the surface of separation, separating two medium. So if the light ray goes straight, it will follow the path BC prime, but it changes its path and follow BC. So this phenomena of bending of ray of light is called refraction. Therefore, when the ray of light travels obliquely from one transparent medium to another transparent medium, the bending of ray of light at the surface of separation of the two media is called refraction of light. Now I will explain laws of refraction of light. Look here. If the angle of incidence is increased, then the angle of refraction also will be increased. But it is not like that. That angle of refraction will not be proportional to the angle of incidence. That is, if the angle of incidence is doubled, the angle of refraction R will never be so. So the angle of incidence and angle of refraction is not proportional, but if we increase angle of incidence, then the angle of refraction also will be increased. So it is seen that if the angle of incidence is I1, I2, I3 and their respective angle of refractions are R1, R2, R3, then we can get sine I1 by sine R1 equal to sine I2 by sine R2 equal to sine I3 by sine R3 is a constant. That means sine of the angle of incidence by sine of the angle of refraction is a constant. So there are two laws of refraction. First law, the incidence ray normal drawn at the point of incidence. Look, the incident ray normal at the point of incidence on the surface of separation, and the refracted ray all lie on the same plane. This is first law. Look, in this figure also, incident ray, here light is incident from the glass medium to air medium. That means from denser to rarer. So incident ray, normal and the refracted ray all are lying on the same plane. Okay. And second law, when light enters obliquely to a transparent medium from another transparent medium, then for a fixed pair of media and for a fixed color of light, the ratio of the sine of the angle of incidence to the sine of the angle of refraction always remains constant. This law is also known as Snell's law. So you have to memorize these two law, and if it comes, write down Snell's law, you will write it. That means the second law. Now I will explain one interesting thing, that is refractive index. For a particular pair of transparent medium and a particular color of light, when ray of light refracts from one medium to another, then if the angle of incidence is I and the angle of refraction is R, then sine I by sine R will be a constant, and it is called refractive index of the second medium with respect to the first medium for that color of light, and it is expressed by n. So refractive index is symbolized by n, small n. Look here, AB is the incident ray and BC is the refracted ray. Here also, okay. And here ABN is the angle of incidence and NBC is the N prime BC is the angle of refraction. If the ray of light enters in the medium B from medium A, then the refractive index of medium B with respect to A. Look here, light is entering from medium A to B. Then A and B, these A and B are the index. So the index which is at the right side, that means light is entering to that medium, and the index which will be in the left side, that will be the medium from where light is coming. Okay, so A and B, that means light is coming from medium A to medium B. That means light is entering from medium A to medium B. So A and B equal to sine I by sine R. That means sine of the angle of incidence to the sine of the angle of refraction is a constant, and that is known as refractive index, which is denoted by N. So here A and B, that means light is entering from medium A to medium B. If the ray of light refracts into medium B from vacuum, then the absolute refractive index of medium B is NB. So if light is coming from vacuum to any another transparent medium, that time we will only write down the index on the right hand side, not on the left hand side. So at that time refractive index can be written as NB equal to sine I by sine R. Therefore, sine I by sine R. Therefore, we can write BNI A. That means here light is traveling from medium B to medium A. Okay. Suppose it happens at the time the refractive index B and A, that means light is coming from medium B to medium A. So at that time it will be reciprocal. That means sine, here it is sine I by sine R, but here will be sine R by sine I. So BNA equal to 1 by ANB. So sine R by sine I, it can be written as in this way, 1 by sine I by sine R, isn't it? We can also write down in this way. So 1 by, but sine I by sine R equal to what? A and B, isn't it? So we can write 1 by A and B. That means refractive index of medium A with respect to medium B is reciprocal to the refractive index of medium B with respect to the medium A. So if you know the refractive index of medium B with respect to A, then you can calculate the refractive index of medium A with respect to medium B, because they are reciprocal to each other. So we can write B and A equal to 1 by A and B, or A and B equal to 1 by B and A. Is this clear to you? So again, the refractive index can also be expressed in terms of velocity of light. So A and B equal to velocity of light in medium A divided by velocity of light in medium B. So when you will express refractive index with the velocity of light in both medium, that time the numerator will be the velocity of the light in medium A. Light is coming here from medium A to medium B. That means medium A is the first medium and B is the second medium. So in that case, refractive index will be velocity of the light in first medium divided by velocity of light in the second medium. That means velocity of light in medium A divided by velocity of light in medium B. And 0 NB, if that means light is coming from vacuum to medium B. So in case of vacuum, in the left hand side you can also use 0, or without 0 you can also express it. So velocity of light in vacuum, 0 means vacuum, and divided by velocity of light in medium B. The medium whose refractive index is greater, density of that medium is greater, and velocity of light is less in it. On the other hand, the medium whose refractive index is less, density of that medium is less, and velocity of light is greater in it. Dear students, this information you should remember. For doing mathematical problem, you will require this. Okay. So today I want to finish my lecture up to refractive index. You will go through very carefully, very nicely, very attentively, because from here mathematical problem can come. So goodbye everybody. Stay safe and stay sound.